Okay, so I sent you a video. The video should be available here.
Hi, I'm Gail Locke-McDowell, author of Cracking the Coding Interview. Today
You can listen here.
we're going to talk about linked lists. A linked list is a very simple data structure. It's essentially just a sequence of elements where each element links to the next element, which links to the next element. A linked list.
I think you will not be able to listen here, but okay, so as I sent it earlier, okay, so please watch it. It's 7 minutes video, okay? If you watch it 2 times or rewind it, it will take maximum 15 to 20 minutes to understand this thing. And if you understand this basic thing, it will be easy for me to go ahead, because there are some basic things that I don't have enough time to finish. It was I was supposed to finish this topic by tonight, but I will not be able. Maybe I need one more class, so I will think that. Okay, so really these topics are hard, and really these topics are hard. I am trying my best to make it easier. Okay, but actually there are no such easy thing that I could make it what is that? Okay, we went through about linked list, right? Actually, this is a very important topic. Okay, so everybody please give full attention. So this is actually second dimension, second area of this class. Okay, so other than object-oriented concept, we cover object-oriented programming concept. Okay, so like these are the linked list. This is actually data structure. This is the foundation. Actually, linked list is the foundation of your next courses like data algorithm and data structure, other classes. So if you do not understand this concept, you will not understand anything in the second half of this class. So if you do not understand tonight's class, you will not understand anything afterwards. Okay, so please let's give full attention. Okay, so we know that like linked list is a dynamic data structure, right? Dynamic data structure means we can add any number of elements in this list. We know that array is a static data structure, because array, when we declare an array, we have to assign its size, a fixed size. If we want to add another element within an array, the problem is that you have to create another array, or you have to shift some or move some elements and then keep a blank space in order to put a new element. Okay, so this is why we use linked list. Linked list is a dynamic data structure that allows us to add any number of data or any kind of data, almost any kind of data. Okay, so this video, it shows a basic concept of linked list, and it also shows the basic difference of array and linked list. For instance, this is a linked list I already discussed. There will be in linked list, by convention, every element is called a node. Every element is called a node. Okay, instead of object, For elements, every element we say node. Okay. Okay, and this is an array. So for instance, this array, there are some advantages and disadvantages of using linked list over using array. Okay, so this video it says the advantages and disadvantages. So for instance, insertion and deletion at the end or beginning of a linked list requires a constant time. But in the middle, if you want to insert any element in the middle of a linked list, then it takes linear time. Because if I want to delete the element 12, then you need to start from 1, from the beginning. Then you have to come here, then you have to come 9, then you can delete 12. If you want to another element, for instance 10 after 9 before 12, then you have to start from the beginning. 1, 2, then you have to come 5, then you have to come 9. After that you will add another element 10 and then join that element with 12. So insertion and deletion at the middle, it takes linear time. Linear times means if your size gets bigger, it will take long time. But insertion and deletion, we know that for array is constant time. Takes constant time, right? But still, okay, we use a linked list because as we discussed that even when we do not know ahead of time how many elements I have to deal with, I have to store how many data. If we do not know it ahead of time, then insertion is the linked list is the best way. So far we are discussing it's called single linked list, okay, and later we will discuss double linked list. Doubly, it's called doubly linked list and it's called single linked list. Single linked list is that in a linked list you see there are some nodes, and each node knows about is adjacent node. Okay, for instance, you are sitting in a bench, right? So each one will know just next to or left side. For instance, who is on the right side. Okay, then even you do not know who is sitting on your left side. Think about that. If you are sitting on this bench, if you know who is sitting on your right side, even you do not know who is sitting on your next left side. Okay, so but if you want to, there is a way that you can, if you are an element or a node of a linked list, there is another way, that is another linked list, that is called doubly linked list. So doubly linked list knows both sides, who are on the left side and who are on right side. But sorry, who is on left side and who is on right side. Only one element. So we will later discuss on doubly linked list, but tonight we will discuss on single or singly linked list. Okay. So linked list is a concept that it will head up. It will have a node. Okay. Instead of telling something by convention, we say node. Every node contains two things. Every node in a linked list contains two things. One thing is data. Another thing is the address or location of the next element. That's it. One thing, two things. What are the things? First thing is data. Every node contains two things. First thing is data. Second thing is the link. The next one, okay? So the PowerPoint slide I have here, okay? So I have here, so I like you to go through this, but I like to demonstrate that the PowerPoint slide, it shows some methods. It has, for linked list, these are the basic operation. Insertion, okay, inserting in the front, it's called prepend. Inserting in the end, it is called append. Okay, insertion is between front and the end.
I want to keep a list of triangles sorted by the depth of the furthest away vertex every frame.
That is called tree. We will discuss tree later. That is the concept of tree. We will discuss tree later, okay? Triangular type data structure, that is tree. We will later discuss. And deletion, sorting, sorting. Okay, these are the basic operations we need to know. No, you're fine. We will discuss that. We will discuss that type of data like tree type or triangular type later, okay? In another class. So, okay, so this thing is a basic understanding, but instead of going this like literal points concept, I want to discuss this through a program, actual program, okay? I want to discuss, so everybody please give attention. And who are in the back, please come either front or come in front of the monitor. Okay, this is very important thing. If you understand this, then you will understand the elements in the next few weeks. This is half of the class. We are on the half of this course, okay? If you do not understand linked list, then you will not be able to pass your data structure class. I'm sure. Okay, so let me open okay, I'm opening Eclipse. I want to show the program in Eclipse, but my entire program is the program I will demo is available on my GitHub account and github.com/CSIT@expert. So the program I will discuss is already over here in my GitHub account, and if you go CS1322, this one 1322 review. How many of you know how to clone a GitHub project? 1, 2. Emily, you know that, right? How many of you know? Please raise your hand. I want to see. How many of you know how to use GitHub? Okay, almost half. That's good. I like everybody to use GitHub. Your life will be easier. Using GitHub is that, for instance, you are using a Google Drive or you are using a OneDrive, and OneDrive, or you are using a virtual drive. Instead of carrying a drive, okay, a flash drive, when you use a virtual drive, there are some advantages, right? You can download your file from any computer. And another advantage of using GitHub is that you can use GitHub. It keeps a track, a version control system. GitHub is a version control system. All change you make, you can get that back. Okay, when we work in companies and then in teamwork, there is no alternative way to use GitHub. So I like you to use GitHub, and if you get stuck in your program, just send me your GitHub account. Then it will be easy for me. I can download your program and then I can work on it. I can save it back. This is my intention to ask you to be used with GitHub. Okay, so then this is CSRC folder, and it has some folders like linked list, and within linked list it has the last program singly linked list explained. So this is the program. It is couple of 100 lines. Okay, is more than 300 lines, about 350 lines. Okay, so the program is already here, you can download it, but I will discuss the main concept, major part. Okay, so if you understand tonight's class, then it will be easy for you. Really, this will be easy. Otherwise, if you do not understand, then really it will be tough. Okay, so every linked list, it has some elements. We say node. These are node, right? These are node. Okay, so we need
the very last element,
okay.
and then inserting the element.
Okay, so we need a class. First class, the class name is node. Okay, we need a class. That class will contain two things. How many things a node will contain? Yes, data and address of the next node. Okay, so it can contain any kind of data. Data can be an integer type or string type or float type or double type or an object type, or also it can contain node itself. Okay, itself type. Okay, so let us try to understand with like a student account. Every student has an ID and a name, right? Everybody has an ID and a name, right? So let us understand with two data elements, an ID, every node. Let us think that every node has an ID and a name. Okay, then if you understand with these two elements, then you will be able to add any number of elements. Okay, so let us understand with two kind of data. Okay, two types of data. Okay, so this is the class node, and it is okay. So what I want to do, I want to okay, in order to make simple. Okay, so I want to delete something because you need this. Okay, so what I want to do, I want to delete everything. Okay, and then I want to delete everything else. Okay, let me save it in a different file. So I will copy from here and then I will paste it here and then I will go through. Okay, so my package name is LinkedList, and then I have there are too many methods over here. Okay, so this is my public class singly linked list explain. This is my class name, that public class, that is my file name. Okay, and I have my main over here. So let me delete everything from the main as well as. Okay, so now it is simple, right? Okay, there is no error. Okay, it's simple. Okay, then for a linked list I need a node class, right? Class node. Okay, what this node class will contain? I need integer ID and string name, right? Two data, and it will contain, yes, so that will be node next. You understand so far? Okay, then I need a method, for instance, to a constructor to add. Okay, so I can say a constructor method, that will be my constructor method here. So this one my constructor. What this constructor is doing, when I create an object of node type, I will provide an integer type ID and I will provide a string type name, right? Okay, that's it, right? This is a constructor, right? Public node. Can a constructor have a return type? No. Even it cannot say void. Constructor cannot have any return type. Even it cannot say void. Okay. 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 So this is my constructor. Okay. Now I need to display ID and name, right? If I want to display a node, what I will display? Only my data. My data are here, ID and name, right? Then I will display ID and name. I need another function method named display. So this is my display. This is my display method. Okay, it is displaying a node, displaying only one node. Okay, what it is doing? Just it is printing ID equal to ID, name equal to name. That's it. Yes. So now, in order to display my ID, what is the method that I need to override? In order to display something, I need to override a method. Otherwise, it will show me address. Yeah, I need to override toString method, right? Otherwise, it will show me what? Address of the object, right? That will not help me, right? So then I need this method, toString method. I can override, I can put override toString method. Okay. So everything is happy, right? There is no error in this program, right? So everybody understand so far? Who did not understand? Please raise your hand. You didn't understand? Who did not understand so far? Raise your hand. Everyone understand, right? Okay, so this is the basic foundation. That's good. If you understand so far, then it's good. So a node will contain data and another node that will contain the address or link of the next node. Okay, so any kind of data we can put. So far I put an integer type ID and a name. Okay, for instance, and then I'm printing over here, displaying a node. This is my method. Just I'm displaying ID and name. You already know this, and in order to display my ID properly, I need to override my toString method. Otherwise, it will not show me my ID. Okay. So now, if I have this, now I can create object, right? I can create a node object, right? What is the way that I can create a node object? Yes, node, tell me, node n1 equal to new node. What I will need to provide? I need to provide two things, right? What I need to provide? An integer and a string, right? For instance, let me put an integer 0, and for 0, let me put a string element, for instance, O. I'm just saving time, so I'm putting O, right? My name ID is 0 and the name is O, right? For instance, then I want to add another ID, another node. Okay, so then I want to put 1 and I want to put A. Okay, then can I do a few more? So far everybody is easy, right? Okay, so I have a few more. Let me, instead of getting from there, let me copy from my code. Okay, my code are over here. For instance, my nodes are here. Okay, so let me delete my previous things and my node. How many nodes I have? 6. Okay. Now let us display the nodes. For instance, how can I display? Then I have 6 nodes. Then so far, if I do this, until then I have 6 nodes, but nodes are not linked each other. These nodes are not linked each other, okay, individual linked, okay. Okay, so this, I just created the node, this node are not linked. So, okay, so how can I display a node? N1 dot display a node. I have a method, right? Display a node, right? Then I can do N2 dot display node, N3 dot display node, right? So I can display all of my nodes, right? Here are my codes, and then I can display my nodes. Okay, so let me, instead of writing one by one, let me copy and paste it, okay? So far my program is good. Everybody understand this so far? Okay, so let me run this program. Let us see what happens. So is this program showing my data? Yes, right? Whatever I entered ID, my first ID name equal to N1, second ID for ID2 name equal to N2, for ID3 name equal to N3, for ID4 name equal to 14, for ID5 name equal to N5. So far it is good, right? But there is a limitation here. What is that limitation? Yes, but each node is distinct from each other, right? From another link. So the link, they don't know who is next to them. A node does not know who is next to him. Okay, so then I have to link them manually. So for instance, if I say N1 dot next equal to N2, I'm sorry, N1 dot next equal to N2, that means N1 gets linked, that is N1 will be the first element and next N2 will be the next one. N1, I joined N1, N2 with N1. Now N1 will know N2. Now N1 will know that who is next to him. Okay, you don't need to type, keep note, okay? Keep attention, and then can you please ask him to wake up? Wake up, please. Yeah, wake up. You don't need to type, to keep note, okay? The program is, the entire program is there. So far you understand? So what does this mean? N1 has the link with N2. Then N2 dot next will be anything I can do. I can say N4, no problem. But I can say, just keep it simple. Let us say the N2 dot link equal to N3. Okay? So I have code already. So instead of typing, I want to save time. So here, let us print it. So before I go there, let us print it. So what I print over here, you see, if I print N1 dot next before I assign, okay, for instance, I do not have this, I have this letter, okay. If I run this program again, then you will see that what is it showing? N1 dot next equal to null, N2 dot next equal to null, N3 dot next equal to null. Every node is distinct, right? It's showing null means each of this node does not know its next element. Null means, right? Now, what I need to do, I need to assign who, for instance, I need to assign who will be the next. Okay, so by this way. So then after put here. Okay, so then let me assign the link. Okay, so N1 dot next equal to N2, N2 dot next equal to N3, N3 dot next equal to N4, and by this way, let me assign. Okay, and by default, I can do N6 dot next equal to null. That means that is my last element. Okay, I can do it, or even this is by default null. Okay, now if I print this again, the same thing I'm printing, right? Whatever I had here, the link, I am printing same thing again over here, but now it will show me the links. You see, after linking the nodes, it is showing me n1 dot next equal to n2, n2 dot next equal to n3, n3 dot next equal to n4, and n5 dot next equal to n6, and n6 dot next equal to null, even if I give this null or do not give this null. So now these elements, these 6 nodes are linked. What are the advantages? Now I got that these 6 elements are nodes. So n1 knows that n2 is next to it, next to n1, right? Okay. So this is a naive way. This is a naive way of implementing a linked list. Why it is a naive way? Because I am manually assigning, right? I am manually assigning the nodes who is next to it. These are the things I am manually doing. So this is not a convenient way. So we need to figure out a way how these assignments, who will be the next node, can be done automatically in my program. You understand my limitation? What is the limitation here? I am doing this assigning, linking. I'm linking this node to each other manually, right? Okay. So this is not a good way. Okay. So now we need to find out a way so that we can do this thing in a better way. Okay, so we want to do that. Okay, so then let me delete this thing. Okay, I don't need this. So we want to find a better way. Okay, so then we delete these things. Okay, then I don't need this. If I need this, I will go back. Okay, so I don't need this. You understand why I have deleted the previous code? Because I link the nodes manually. But that is not a good way. So I need to find a way. Okay, the better way to implement a linked list is, by convention, create another class. Okay, create another class. By convention, that class name is linked list. Okay. What this linked list will do, this class will do, it will contain the node, as well as it will contain a constructor. Okay, a constructor that will create a link with null. We create a node with null. What is that? Null pointer to next. Okay, and it will contain all of the operations that we want to learn. Like the operations are these operations: insertion, deletion, searching, sorting, this stuff. Okay. So now, our goal is to implement or expand this linked list class. Okay. So I already have some codes. Let me copy and paste from there. But as always, I will try not to copy everything. I will try copy and paste part by part. Okay, so that you understand. Okay. Okay. Okay, so this linked list will contain a head or a node. Okay, contains node. Okay, I have node class, right? Node and elements. There by default name is head. Okay, so this linked list will contain the thing. What is that? Node. an element of node type. Okay, we are calling this as head. So what does a head contain? What does a head contain? Each head contain two things, right? Data and next strings, right? So by default, okay, so by default, every new linked, okay, so when we call this linked list class, it will call its constructor, and then constructor will make the head null. It is null initialization because we want every node by born will not know who is next to him. For instance, when a new baby born, at the moment a baby born, the new baby does not understand who are their parents, right? But later, when the baby comes in contact with mother and father, they understand, they come to know who are their parents, right? We know that. For a single thing, that for instance is a head is a newborn baby. Still, he does not know who is his or her mother. Okay. So far are good, right? So this null initialization is optional. Even I do not put this head equal to null, still it will create, as we have seen earlier, right? That every node when it creates, it next head dot next equal to null, right? Okay. So then one thing we need. So everybody understand so far? Why do we need this class, linked list class? Yeah, we want this class. We need this class so that we can link nodes to each other easily. Okay. So the first thing of this linked list class, this class name be anything. You can name this class anything. You can save this class in another package or by new file, in another separate file. Okay, but I'm putting in wall file. Okay, so my node class is done. So I don't need to do anything for my node class. You see the node class started here on line number 3 and it ends on line number 22. My node class is done. I don't have to do anything for my node class. Okay, what I will do, I have to work on my linked list class. I have to expand my linked list class with insert operation, add, delete, search, sort, all other operation I have to put within this linked list class. Okay. Now let us add more elements. So how can I see, okay, whether a linked list is empty? Okay, there are two ways. One way that thing that is if head is null, right? Then this linked list, this class, this is head is null, then this is an empty, right? Head is null means this in the linked list there is no node. Another way, that could be another way, that if I create a size variable, if I do another variable, size variable, okay, then if it's my size is 0, then okay, that could be another way. Okay, so let us stick with one way. In another example, you can see that there is another way to see that isn't. So my isEmpty function is returning head null. That means if head is returned head equal to null. That means whether if head equal to null, then it is returning true. Otherwise, it is returned false. So if it returns true, that means this linked list is empty. Okay. Okay, now I need to, let me see here. Okay. Now I need to create node. Now I need to create node, right? Each of this node. For instance, let me create a node. This one, individual sum nodes. As I showed you earlier how to create individual nodes, right? But this time, since I have a different method, linked list method, so I will create my node in a different way. Okay, so let us see how we can create my node. Let us go back to main. So within my main method, I will create an object. How can I create an object? We know that, right? We are creating an object of linked list, okay? And then how can I create an object? Linked list, for instance, my element, my linked list, for instance, my object name is the linked list, okay, equal to new linked list, right? Is there anything new here? Nothing. You know that how to create an object, right? For which class I am creating an object? For this class, linked list class, I am creating an object. Okay, so I want to save some space. Okay, just this is the simple way. Okay, now how can I create a node? Okay, so now, okay, sorry, I created a node. Okay, so then I need to do add, for instance, here element. Okay, I need to first create a node, and then I need to add a node. Here I have created a node. This line, it will create a node, but I need to write a method so that it can do two things. Okay, the first thing it can do, let me show you. It will create a node. That single statement will create a node, but it will do two things. One, it will, first thing, it will
There. That will take linear time.
the first thing, it will put its data in place, and second thing, it will link this node with its adjacent node. Okay, so actually I am going to write a method for add operation. Okay, how to add a node, which says node, right? Node element in my linked list. So far my linked list is empty, because here I just created an element, right? I don't have anything here. I did not put any node element here, right? And now I cannot do linked list dot what is that method? I need to use this method, right? Constructor, in order to put data. But so far I don't have any option to call this constructor, node constructor, so that I can put my data. So I need to think alternatively. I need to create a method, for instance, add. So if I have a method add, I can define a method add. So then I will be able, if my add method calls this constructor, right, then I will be able to add my data. Okay, but adding, in addition to add data, I have to think another thing. What is that one? Link. It needs to be linked, right, with another thing. Okay, so but before that, Okay, so far my linked list is empty. It does not have anything. And so it does not have anything. So there is no link. There is no question to tubular link, right? But there is no node already. Okay. But we are thinking to write a method so that I can create a node as well as I can link it. So when I want to add an element in my linked list, then for instance I have to think different way. For instance, let me show you one thing. So for instance, I have to think if my linked list is already empty. If my linked list is already empty. So whatever method I will add in this class, okay, over here. So for instance, let us create a method add. For instance, public void add. Okay, let us create a method add. Okay, so then in the add method I have to think that I don't have any node in my linked list. So the first thing that if I have head, if my head is null, that means what is this means? Empty, right? Then I have to put head equal to new node. That I am putting head as a new node over here. So why it is showing an error?
You have to take parameters. You don't have parameters. You need to add an ID and then string name.
Oh, sorry. Yeah. Integer. Thank you. ID and then string name. It is fine, right? Then what this add method will do? Okay, so now is happy, right? Add ID, for instance, let me do 1A. This add method is working, right? So let us add a few things, add a few nodes. Okay, 2, 3. Let us try with 4, no problem. So B and then C and then D. Okay. So can anyone tell me that? So I don't have any method display yet. So I cannot display yet. Okay. Okay. So let me create a method to display my element. To display all nodes. This is the method that will display all nodes. Okay, I will explain you later, but let me go. This method will display all nodes. Okay, it is starting from head, and then while I will explain this later. Okay, but for instance, let me get this and let me call this. Let me see whether it works. Okay, so then I have my linked list. I have how many elements I have? 4, right? Okay, so then the linked list, if I call it dot display all nodes, right? I added this method display all nodes. Okay, now if I run this program, what it will show? Okay, this is displaying only one node. Why? Okay, it is displaying only one node. But in my method, I wanted to display. You see that method, my method here? Let me now explain this method. In my method, I want to say I created a node, the node equal to head. Okay. Okay, and then, okay, so what is the meaning of this line? Initialize the node with head. That means every node will know who is the head. Head is the top one by default, okay? So then while the node dot next equal to null. Okay, I will explain it that later. Okay, so I am displaying the node dot display node. Okay, and then I see that the node equal to the node dot next. I am moving forward. I am going next one. This method is supposed to design to display all elements, but it is so far displaying how many elements? Only one node. Okay, what is the reason?
We haven't finished the earlier method. Add only is set up to add.
Yes, it's a setup since my is add. Okay, it's just add data. It has not created a node link. Okay, this add method is incomplete because what it has so far, only it adds data.
Well, it only adds one, because after head won't be equal to null.
Yeah, so it's distinct. Okay, so now we have to rethink about add method. So when we rethink about add method, then we have to think two ways. For instance, now I have one element in that array, right? One node in the linked list, right? Now question that I have, for instance, one node. Then question is that when I want to add another one, next one, then there are two questions over here, two situations over here. Whether I will add the next node on the right side or left side. You understand? When I had my empty linked list, I did not have any issue. I just created one node. Fine, right? But when I have one node, then the question will come, where my next node will be. Right here? So I have one node, node 1. So then the question will be, I don't know why they cheap this, why they don't throw this out. Can you please give me plastic? Can you please give me favor? No, not right now. When you leave, throw this out. I'm sorry. Okay. So when I have got one node, then the next question will be when I want to add another node, or when I have already some nodes. Okay. Then the question will be whether I will add my new node on the left side or in the next side, last, or in the front or at the end. Okay, this is an important thing. Okay, so when we want to add, if we want to add a new node in the front, okay, that is called prepend. If we want to add I already got a node, right? With my add method, my add method is creating a new node, right? On node, then the question will be whether I will add another node on this left side or right side. So left side, if I want on left side, then it is called prepend, and if I add on the right side, it is called append. You understand? Okay, so let me add my append method first. So that means my add method does not work. So this way my add method will not be sufficient, right? So that I don't need this add method. This add method is not working, right? Why it is not working? I added 4 nodes, but it is showing me only one node. So that means my add method is not sufficient. So let me delete my add method, okay? So then, instead of add, I need 2 methods for add purpose. One is called append, that will add at the end. So Oh, I'm sorry. So this is let us draw this append method first. Okay, so in the append method, same thing I have to consider if my node is empty. If there is no node. Okay, the same thing here, right? This is the same code, right? The same code I copied here. Okay, same thing. And in addition to this, what was my limitation in this add method? I did not create a next node, or I did not create a link. So this is the part actually. So this part already I have here. Same part. So let me delete this part. Actually, I don't need this method now. And here are the additional stuff I need. These are the additional stuff I need in order to make append. What is an append? Append means a new node will be added here after that. For instance, let me consider that I have this node with data value 19 or ID 19. If I want to add a new one, okay, then what do I need to do? Two things I need to do. One thing is that I need to put my data. That is it doing here. If it's empty, then it is getting here. Otherwise, it is creating, for instance, it is creating a current node. Why do I need to current node? I will tell you in a second. Okay. So while next current node dot next not equal to null, actually data is adding here. Let me explain this how it works. Okay, when I want to a new node, for instance, I already have a node, right? If it is an empty, then it's creating a new node, right? So I am using append method. That means I already have a node and I am ending at the end. That means when I create another node, I need to say this node, I need to link this node with that one. Okay, and I need to put this link dot link equal to null. So if this is my last one, then I need to link this previous node with this node, and this is the thing I need to do, and I need to put new node. This is my new node. For instance, this is my current node. This is my current node, and this is my okay. So this is my current node. The new node I'm okay. So then I need to create a link to a null. Let me okay. So this is where what I'm doing. Node, I am creating either a current node, or I can make it as a new node as well as. Maybe it's efficient to use new node instead of current node. It was okay, current node, new node. So current node, I am creating another node current node equal to head. Okay, then while current node dot next not equal to null. That means I am starting from here, since I will add all the way in, right? So that means while current node, this is my current node, this is my current node, this is my current node. While this node does not until this node does not have a null pointer, I will go through all the way end, and this is my here. This is that. While current node dot next not equal to null, I will go current node equal to current node dot next. Okay. One thing that I forgot, okay, to explain. Let me explain that one. Okay. Another thing is that link is. Another thing, remember that. So this node has data 1, right? Okay. Okay. So this is my, for instance, let me say this is node 1. Okay. Then this is node 2 and this is node 3. Can I do this way? Okay, so let me see, this is my node 1 and this is my node 2, this is my node 3 and this is my node 4 and this is my node 5. I could write on board, okay, but I'm writing here so that later you can revisit. You can revisit my lecture. Okay, so for instance, let us think that this node contains data, for instance, 1, ID 1, okay, and this node contain ID 5, this node contain my ID 9, this node contain ID 12, and this node contain ID 19, okay. So this node dot next will be second node. Second node dot next will be third node, okay. So if I say node 1 dot next, that will be second node. If I say node 1 dot next, that will be third node. If I say node 1 dot next, then it will be fourth node, right? So then if I say node 1 dot next, then it will be fifth node. You remember that? Okay. If I say node 1 dot data, then what will be my node on data? 1, right? If I say node 1 dot next dot data, then it will show my 5. Okay. If I say node 1 dot next dot data, then it will show me 9. Okay. So this is this code. Okay. So maybe I'm out of time. Can we give 5 more minutes? I want to finish this one. Okay. Okay. So this append method, this is here. What it will allow me to add as many elements as I want to add. Okay. For instance, if I say the append, you see, whatever ID I say 1 and name 1, name for instance A. Okay, let me add here. Okay, now if I add 2, 3, 4, for instance, this on B, this on C, and this on D. Okay, so now the advantage of that, I have same display all nodes method, right? Now this time it will show me all nodes. You see that it is showing me node, first node equal to 1 and name equal to A, right? Second node will be ID 2 and name equal to B, and third node C, and then next node is D, right? So that so every node it is showing its next node, right? Correctly, it is showing me A. When I am appending this node, that means it is going A next to A. So then it is showing me the next element. So this append is one kind of addition at the end, right? But there is another kind of addition we discussed. Give me 2 more minutes, please. Let me finish up. That is called prepend. Prepend means if I want a new head here. Okay, so prepend in this lecture, if you go to this lecture, okay, this is the append. This shows the append, okay, adding next, okay. But now we need a prepend. Prepend means I already had one and I am adding a new one. I already have this, okay, and I want to add at the beginning. This is called prepend. If I want, so far my append method will add on the right side, but as I mentioned that I may need to add at the beginning, top, right? So then this is called prepend. Okay, what my prepend method will do, I have already this node has link with this link, but I have to put data here as well as I have to link over here. Okay, so I have my code already over here for append. Okay, this is my code for append. So if I put my code for append over here, let us see the difference between append and prepend. You see, this part is same. This part is same if it is empty. After that, I am creating a new head equal to data, so that my new head here, it will contain data, as well as new head dot next will be that head, right? Okay. So new head dot next will be head, this one line, and I have to head my head. Previously my head was this one, then I have to put my head here, right? This one will be head, the top. So these two lines I need to do for prepend. So now I have my prepend method. Now if I say, okay, now I instead of append over here, if I say prepend, what it will do? Can anyone please explain me? So here I'm almost done. Okay, give me 2 more minutes, please. So my first node will be A. Here, for instance, let me start with A, right? A, right? Okay, so instead A, I can put 1. My first node will be 1. Okay, the another second node will be 2. Then I am prepending 3, right? 3 will go where? 3 will go. This is my 3, right? This 3 will be linked with this one, and this one will be linked with 2, and this one I'm appending 4, right? Where 4 will go? 4 will go here, right? 4 will go here, and then link will go this way, right? Link will go this way. Now let me see whether my output shows that way. If I run my program, you see what is my first top one? C, right? And who is next to it? A, right? It says next node is A, right? Then A has next node B, and B has next node D. You understand? So this is the 2 ways of adding elements. One is called method append, and another is called prepend. Prepend adds at the first, and appends at next. Okay. So this method, it says append and only add. Okay. Then I have another method, search. So then if you go to my code, then you will see that I have remove first. Remove method. If you want to remove from the top, or remove from the bottom, okay, and then if you want to search by ID, find or search by ID. You can find by name, okay, find by name, or you can remove a link, remove a node. Okay, there are several methods. Okay. But if you understand at the basic things, what are the basic things? The node and the class LinkedList, right? LinkedList class, right? If you understand the append and prepend method, then you will be able to understand other methods. First, let us do first thing first, okay? Try to understand, try to be clear with the append and prepend method first. Okay? If you understand append and prepend method, then it will be easy for you to do other methods. Really, this is a tough thing. You need to sit with cool mind, okay? Okay, so please go through and let me know if you have any question or if you need help, okay? Thank you so much.
Before you get out of that, so I was trying to